This is problem number 84, page 233, section 4.5. And I'm going to do a complete analysis of this polynomial, including graphing, in part based on what we've learned in section 4.5, and also following the summary of how to analyze the graph of a polynomial that is on page 185. So I'm going to start with step 1 of the summary on page 185, and it says, determine the end behavior of the graph of the function. So I'm looking at my function, and I see that it is written in standard form. I'm going from highest powers of x to lowest powers of x. And so my highest power of x is to the 5th, which is odd, an odd number. And I see that my leading coefficient is 4. And there's no negative sign, so it's positive. So odd and positive, I always think of the graph of x cubed. What's the end behavior of x cubed? Well, the graph of x cubed has a point at 0, 0, at 1, 1, and at 2, 8. And at -1, -1, and -2, -8. So the graph of x cubed looks like that. So that is down, up, end behavior. So I'm going to go over to my graph, and I'm just going to make a little note, like I like to do, that it's going to be down, up, end behavior. That's what my graph's going to end up being. The second question says, find the x and y-intercepts. Well, the y-intercept is always easiest for me, because it just means I have to evaluate the function for f of 0. So that means 0, 0, 0, -3. So I'm going to go to my graph, and I know that I'm going to have a y-intercept right there at -3. Now the x-intercept isn't quite as easy. You remember, if I'm looking for an x-intercept has a number of different terms. It can be called the x-intercept. It can be called a 0. It can be called a root. It can be called a solution. And a related term is a factor. It is not the same, but a factor is in the form of x minus some kind of a constant. That is a factor. So intercept, 0, root, solution, those all mean the same thing. And how I'm going to find those zeros is I'm going to use the rational zeros theorem. This is my P, this is my Q. I need to take all the factors of P and all the factors of Q. So P, being 3, has factors of 1 and 3. Those are the only factors of 3. And Q, which is 4, has the factors of 1, 4, and 2. 2 twice, as a matter of fact. The 1, 4, and 2 are the factors of Q. So I need every combination that I can think of factors of P divided by factors of Q. Well, one of my factors of Q is 1, and it's always going to be 1, because 1 is a factor of every number. So if a factor of Q is 1, that means 1 and 3, or 1 over 1 and 3 over 1, are automatically potential rational zeros. But I have these other factors. I have 1 over 4 and 3 over 4. Those are both possible factors. Those are factors of P over a factor of Q. And I also have 1 over 2 and 3 over 2. Those are also possible rational zeros. And all of these are plus or minus. Any of those can be plus or minus. So I have to be able to identify a list of my rational zeros. That is the list of my rational zeros. You have to be able to know how to do that. Once I've identified my list of rational zeros, I'm going to go to my graphing calculator. And I entered in the equation, and I'm going to go zoom 6, which is always where I started a graph. And that's what I get. So I need to adjust my window. I would like to adjust my window so I can see this a little bit better. So I'm going to go, and I know it's down up end behavior, so I'm thinking at the top of that first segment right here, somewhere up there, there's a turning point and it turns around. So I'm going to change my window. I'm going to widen it out to like -4 and +4. And I'm going to raise my x maximum. I'm just going to guess up to, oh, I don't know, I'll go up to 35. The number I picked out of the blue, and I'll make my scale 3 so I don't have too many tick marks, and I'll just push graph and see what happens. Nope, I didn't go high enough. So I messed around with it a little bit, and I decided to try a y maximum of 80. After a couple of tries, I did that, and I got a graph now that shows me the full curvy part of the polynomial. So I'm looking at the graph, and I want to see, do any of the zeros, remember, zeros, x-intercepts, roots, solutions, do any of the zeros look like any of my rational solution possibilities? Well, I would say that this one right here looks like my best bet. That's crossing right through the point x equals -3. So I'm going to test it using algebra. You have to know how to do this using algebra. I'm going to test it through synthetic division. So I'm going to write my, I think it might be x equals -3. The related factor for that would be x plus 3. Okay, the value for x that would make this equal to 0 is -3. And I'm going to write my polynomial here, so that I can do synthetic division. So I have 4, 12, and then I have to fill in my 0 placeholders. I don't have any x to the third or any x to the second. I have a -1 x to the first, and then I have -3. So I've set up my polynomial my synthetic division here, and I am going to try and do that synthetic division by -3. All right, let's see what happens. I'm going to pull down a 4. I get -3 times 4, -12. I add 4 and I add -12 and +12, I get 0. -3 times 0 is 0. 0 plus 0 is 0. -3 times 0 is 0. 0 plus 0 is 0. -3 times 0 is 0. -1 plus 0 is -1. -3 times -1 is +3. And -3 times plus +3 is 0. So my remainder is 0. And in fact, I have now proven that x plus 3 is a factor of this polynomial. Now, looking at my graph over here, I don't know, these two numbers here, these two zeros right there, well, they're less than 1. But they certainly look bigger than a quarter. Let's scoot this up a little bit here. They look bigger than a quarter. They might be 3/4, I'm not sure. But rather than do synthetic division with 3/4 right off the top, which I could try that, but I think what I would rather do is take another look at my my polynomial. So I know I have one factor that is x plus 3. And I want to look at what I have remaining and write it in polynomial form. I want to write it in standard form. So I depressed my equation. I had started out with a power of 5, the highest degree of 5. So now I have a highest degree of 4 since I have pulled out 1x. So I have 4x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 1. And I'm going to write that just a little bit more easily. X plus 3 times 4x to the 4th minus 1. Well, I think that you have to be able to look at this 4x to the fourth minus 1 and see that that is factorable. It's possible it could have been not factorable, unlikely, because I know I have these two other zeros over there. But you have to be able to see that that is the difference of two perfect squares. That is the difference. Let's put my other parentheses here. This is the same thing as x plus 3 times 2x squared minus 1. And we know that a squared minus b squared is equal to a plus b, a minus b. This is the difference of two perfect squares. This is one of those things that you really need to know. You need to be able to recognize a plus b times a minus b is equal to a squared minus b squared. Which means that I can factor this even further into x plus 3 times 2x squared minus 1 times 2x squared plus 1. So just kind of going back to my graph here for a minute, because I did get a 0 at -3, and I want to make sure that I have the satisfaction of putting it in there. There's one of my zeros. But I'm going to go back to my factoring here. And I'm going to say, can I see any more zeros? Well, so I have the one here at -3. Looking at this piece right here, I need to set either this piece to 0, or that piece to 0, or both to 0. So I'm looking at this piece here, and I see 2x squared plus 1, and I can set that equal to 0. I would get 2x squared equals -1, and I already see that I'm in trouble, because if I just kind of keep following this out here, I would divide both sides by 2. I would get x squared equals -1/2. And I know that when I attempt to take the square root of that, I can't take the square root of a negative number. So the square root of a negative number is not going to give me a real 0. So I'm going to turn my attention to the other one. 2x squared minus 1, I'm going to set that equal to 0. And so I have 2x squared equals 1. I added 1 to both sides. I have x squared equals 1/2. That means I can take the square root of both. Square root of x squared is equal to the square root plus or minus of 1/2. But I have to rationalize that. So I get x is equal to plus or minus the square root of 1 over the square root of 2, which equals 1 over the square root of 2. And I'm not allowed to have any radical signs in my denominator. So I'm going to multiply my denominator by radical 2 and my numerator by radical 2. And I get the answer plus or minus radical 2 over 2. So I have now found my other two zeros. I have a 0 at -3. I have a 0 at radical 2 over 2. And I have a 0 at negative radical 2 over 2. And if I was to write this in factored form, it would be x plus 3 times x minus radical 2 over 2 times x plus radical 2 over 2. Well, let's test it. Let's kind of go back to our calculator and take a look at it. So the first thing, I'm going to erase this here. And the first thing I'm going to do is I'm going to go to just my regular calculator and I say, what is a reasonable decimal approximation for radical 2 over 2? So I'll go radical 2 divided by 2. So 0.707 is approximately what radical 2 over 2 is equal to. Well, let's go back to my graph. I want to find this 0 right there. going to go second, calc, 0. And I want to find the 0 that's over that way there. I can't see it very well, left bound. But I'm going to say, well, it's between, my left bound is -1, and my right bound is 0. So I have my little arrows, and it looks like my 0 is between those 2 points. I don't want to make a guess. I'm going to press enter. And what do you know? Negative 0.707, which is this number right there. I'm sure that the other one, second calc, 0, is between 0 and +1. That's going to be positive 0.707. So that's this one right here. So I have now found all of my zeros. Let's put them into the graph. About 0.7, that's a good spot to put it. So one of them is right about here, negative 0.7. The other one's right about there, positive 0.7. Those are close enough. And if I go back and look at, I want to look at what are the multiplicities of these zeros. Well, here it's written in factored form. So my -3 has a multiplicity of 1. That means that's a cross. My positive radical 2/2 has a multiplicity of 1. That's a cross. And my negative radical 2/2 has a multiplicity of 1. That is also a cross. So if I'm just sketching out my graph now, I'm going to start from here, going somewhere down. I'm going up. I'm going to cross through -3. Somewhere I'll turn around and cross through 0.707. Somewhere I'll pass through -3 at the y-axis, and I'll go up past that. And my graph should look something like that, which, when I look at it on the calculator, well, it doesn't look quite like that. But you know, that's partly because of the way I have my my scaling done. But it looks kind of like that. I have the right end behavior, I have the right touches and crosses, I have the right intercepts. The thing that I am missing here is I'm missing the values for my maximums and my local maximums and my local minimums. I could find those values using calculus, but since we're not doing calculus yet, I'm going to use my calculator to find those maximums and minimums. So I have my first maximum is right in here. And I only have 2 turning points in this graph. So I only have, in this particular graph, I have 1 maximum and 1 minimum. So I'm going to go second, calc. I want to find my maximum first. And I'd say that maximum is somewhere between, I'm going to guess -4 and -2. So I'm going to hit, I don't want to make a guess. I know it was a -3. So I have a maximum. No, it was my 0 that was in -3. So I have a maximum. So I have a maximum of 79.02 at x equals -2.40. That is my maximum. So as you can see, this one here really should be kind of like way up there, turning around. But again, I'm not so concerned with that until we actually have to label and number the maximums and minimums. I want to find my local minimum. Second calc, I want to find a minimum. I know that minimum is between -1 and +1. I hit enter. I have a minimum. So I have a minimum of -3.2 at x equals 0.266. So my minimum is not exactly on the y-axis. It's a little bit over to the side. It's not right on the y-axis. It is not my minimum is not negative 3, it's a little bit lower than negative 3. Finally, I need to talk about the domain and range of this equation. Well, from the graph, I can see that my x values are going to continue going forever negative and forever positive. And this is a polynomial. I might have even described it as a polynomial. And we know that the domain of all polynomials is all real numbers, negative infinity to positive infinity. That's the domain of all polynomials. What about the range of polynomials? Well, the range of polynomials are the valid y values. This one goes down forever and up forever. So my range on this particular function is also negative infinity, the lowest value first, to positive infinity. That's my range. Now, if my polynomial had been of an even degree, I would have had n behavior either up, up, or down, down. My polynomial could have looked something like this. And if it's of even degree, my range is not going to be negative infinity to positive infinity because my n behavior on both sides is going to infinity. To positive infinity. In this particular case, positive leading coefficient. In this particular case, now I should make this a little bit more distinct, so I will here. My minimum for the whole function is right there. So whatever that point is, I don't know what it is. I'm going to just call it negative 4, 8. The y value of that point there is the minimum that it goes. So my range in this case would be inclusive, not parentheses. My range would be negative 8 to infinity. Lowest y value to highest y value. You have to be able to know your domain and range as well. And that is a fairly comprehensive view of everything that is in 4.5 and before. That's a good analysis of a polynomial.